Let's open our eyes to the world that's around us. Science has the answers to the questions that have found us.
Malia Science.
So, what should we do a science video about this week?
Ooh, I have an idea. What if we do one on electricity?
Great idea, great idea. Now, we're going to do one on electricity. But remember, kids, we don't want to mess around or play with electricity at home, or you'll get grounded. That's a little electricity joke. But no joking aside, electricity can be dangerous, so make sure your parents are with us before you do anything with electricity or light sockets or anything like that. So let's go over to our pieces and parts table and check out some circuits.
Yeah.
All right, guys. So first, before we start, let's have some lights. All right. If only it was that easy to snap your finger and the lights came on, but it's not. You see, in order to have lights, you have to have a complete circuit. And that's what we're going to talk a little bit about today, circuits. And every circuit starts with a power source. Right here, we have a battery. A battery is a good power source. It's used in flashlights, toys, a lot of different things. Now, in this battery, do you think this battery is filled with electricity?
It powers the circuit. Yeah.
Not quite. This battery isn't filled with electricity. It's filled with chemicals that when both sides are connected by a conductor, it will allow electric current to run through it. So right now in here, it has potential chemical energy. Potential chemical energy, all right, inside this battery, right? Now, if I connect it with a conductor, a wire, a metal wire, now the electricity will run through the wire. So, here we go. Let's see. Right now we have chemical energy changing to electrical energy and flowing through this wire. Whoops, not anymore. But not very impressive, is it? No, we can't see the electrical energy. It's not doing anything for us. So, really, a circuit like this doesn't do much good. We need to connect something else to it to change that energy again. Energy likes to change forms. We change the forms of our energy quite a bit to be useful. All right, so zoom in here, camera girl of science. All right, let's see. Now here is another power source. Two batteries together to give us a little bit more.
What are we going to start off with?
Right.
This one.
Let's start off with some light. All right, now, we zoomed electricity through that current, and it really didn't do much. But when I let the electricity go through this current, or the current go through these conductors, the chemical energy to electrical energy, and now that we completed this circuit, it is changing to light energy.
Careful.
A little bit of heat and light energy. Now it's useful. See, what happens is, let's explain that. Let's turn that on a minute. So, we have our power source, our batteries. The electrons are going through the conductor super fast. And then they get to the little part of the light bulb called a filament. That's a semiconductor. And the electrons can go through it, but not really fast. They slow down, they run into each other, and when those electrons run into each other, they create heat and light. And then they travel along the black line and back to the battery. So that is a simple circuit. Now, if we add this guy to our simple circuit, we have an on and off switch.
So now we could control when that power goes through?
Yep. We will just connect this guy in here, hopefully, if it's working. Whoa, that isn't going to work at all. Now, so, camera girl science, you can see our on and off switch is open, the light goes off. It's closed, the electrons can run through. So again, go ahead.
Is it because this metal here is touching, because it's right when I take it off that metal?
Right.
There.
That metal is a conductor. If we take a close look at our wire, let's look at this wire. Here's some wire cutters. All right, this wire is a conductor, but it's wrapped in an insulator, because if I strip the wire,
Why would you want to take the rubber off of a wire, like strip it?
well, if you want to make a new connection somewhere else, oh, there you go. So it just stripped the insulator off the wire. So if I wanted to make a new connection to another battery or another light bulb, it wouldn't want the insulator touched, because the electricity can't go through the insulation. So sometimes you need to strip that. But we need that covering, because watch this. If we don't have that covering, all right, right there. All right, so we have our lit circuit here. And if I didn't have that insulation, if these two wires touched, then the electricity would just go through the short path. It would short circuit, and you wouldn't get your light bulb to light. Kind of like this. Electricity is pretty lazy. It likes to take the path of least resistance. If it can avoid going through the light bulb or some other form of resistance, it will. So you don't want it to short circuit. That's why your wires get covered in insulation. Also, when it does short circuit, it can cause, a heat buildup, which can cause a fire. So that's why you want your wires nice and new. And sometimes they put one of these fuses, this is an old time fuse, now they have circuit breakers, into a circuit in a house so that this will blow before the wires get too hot and cause a fire. So this is what we would call a simple circuit. Another type of circuit we might look at is a series circuit.
Huh?
Yeah.
When it has multiple things that it tries going through?
Yep, this is a series circuit we're going to make, and it's two light bulbs in a row in a series, like you have a series of books. All right, they didn't light up as bright that time. That's pretty cool. But watch, this series circuit, we have our power source, electricity, light, back to our power source. And that's a series circuit. The thing about a series, it's kind of like Christmas tree lights. If you undo one, they both go out. So buildings and stuff like your classroom, they're not run on a series circuit. They're run on...
I wonder how many things we could power at once with just those two batteries.
Oh, that's a good question.
Batteries.
Batteries?
Mm-hmm. See if we can get that on, anything. This on.
Clip these in. And clip this one in. Oops. And see what happens here. All right, right there, this is called a parallel circuit, and it's very fragile because I didn't hook them up real good. But this is a parallel circuit. These aren't straight lines, but you can see it's going parallel, parallel. And if I unhook one this time, the other one stays on. So that's like what your school is on, a parallel circuit. And if these were straight lines, they would look like parallel lines. That's why we call it a parallel circuit. But okay, so again, last thing, we hooked up our power source, chemical energy, change it to electrical energy to light and heat. But we can also change it to different types of energy. So for example, here's a motor. What do you think we're going to change it to now?
Speed? That's going to spin really fast.
All right, we are going to change it to energy of motion. All right, maybe. Oh, there's lights.
Looks like a plane.
Yeah, it does. So again, we have our chemical energy turned into electrical energy, and then the mechanical energy of this motor turning. So we can cause that to move. Again, this is a fan from the inside of one of your computers or Xboxes, and sometimes you need a bigger battery. And try the green one on the red. Oh, there you go. There you go. Nice fan moving. All right.
Huh.
And now you can change it to something else. Let's change it to something else real quick. Here's a speaker. Real quick, we're gonna hook it up to the back.
Would that make noise? How would it?
It would, nothing major, but you can see. Now we have chemical energy to electrical energy to some energy in motion, but also sound energy. Here's a little. We'll try another one. I hear it's buzzing a little, but it's not. Oh, there we go. Huh. Interesting. Check your connections over. This is a solar panel. Now this one, instead of having the chemical energy in our batteries, it changes solar energy to electrical energy, and then it'll change it to energy of sound or energy of motion, whatever we want. But we would need a whole lot of these or a very bright light hitting this for this to work. But if you get enough of them, it will work. And you don't have any of the chemicals that are in a battery. One more. We're going to finish up with one more. Here we have a simple iron nail, and it's got a wire wrapped around it. And we are going to run an electric charge through that wire. And guess what's going to happen? Boop, boop, boop. Nothing. But let's hook this wire up to our other battery.
Is it going to become a magnet?
It is. It's going to become an electromagnet. Doo-doo-doo. And now, what's cool about electromagnets, guess what? Yeah, that's stuck on there. Hang it back on for a sec. All right, what's cool about an electromagnet is you can shut it off and on. So I unhook it, the current stops, it stops being a magnet. Whereas a regular magnet, you know, you can't turn it off. You'd have to shake it to get rid of it. So if you wanted to pick up a car in a junkyard, you don't want to have to shake the car. You want an electromagnet to turn it off and on. All right, guys. Well, that is a little bit about circuits. There's a whole lot more that we could talk about, but that's just a brief introduction to circuits and electricity. We'll see you next time.
Bye, Malia gang.
Let's open our eyes to the world that's around us. Science has the answers to the questions that have found us.
Malia Science.
Science.